inside that you draw a circle. Then you will definitely do a cube. Can you draw it? Let us see. These two diameters also you can show. Similarly, you draw another figure like that. Another figure like that. A cube or a square, whatever you like to draw, you draw it. A circle inside. Then you draw another cube. A circle. So 3 figures I have drawn. The other dimension I am not showing. So you can imagine, its trace over here. Other dimension. So this circle is a projection on this plane. The sphere is inside the box, Just to explain how the things will happen, I have brought it here. Or you can imagine a section, passing through this. Similarly, this section passing through this. Like that also you can imagine. You understood what I have drawn? Now, I am giving a deformation something like this. I will just show this face. Other face we will not show now because it put in complicated. So I am just showing it. So just I pressed it and it becomes an ellipse. So this is the longer axis of the ellipse, this is the shorter axis of the ellipse. So you can think 3 dimension way. The other dimension also you are unable to see it, but it is that side, like this, You pressed it this way so that the material went this way, material came like this, so it became an ellipse like this. This case, what happened? I will give a couple to it. Come. This became like this. Here also I am producing an ellipse out of this. So by giving a couple, I am producing. You are able to see the last page, okay, So this is a simple shear deformation. This is a pure shear deformation. This I have already told you. No difficulties so far. Now, what I am doing, this circle also I can make an ellipse without this business, without doing a pure shear. This is a pure shear. This is a simple shear. The structures what I am going to see now, we will discuss folds, body, cystosity, everything will be explained in terms of these deformations. So, but you should understand what are those deformations first of all. Then only we will be able to explain. Now, this is a different picture which I am doing like this. Now, imagine this box is made up of small strips like this, Innumerable strips like this. As innumerable strips are there. It is not a box like this, solid box like this. It has lot of, it is made up of stack of sheets like this. And over that I have drawn this circle. Understood what I am doing? Now, I will remove this strip. Very close lying strips, very close lying strips, not so far apart. So I will remove one strip, then another strip, like this, and keep it there. So what will happen to the circle? Are you able to understand what I am doing now? See, these strips are not very thin strips, just like playing cards. I will remove this card, next card will be there, next card I will remove, next card will be there. So this width, will reduce. If I remove the cards from it, So what will happen to the circle? This will also become an ellipse. Huh? So this will become like this, you know. This dimension will also be reduced. This dimension will remain same. And this circle will also become an ellipse. Follow this point now, what I am doing. So this is not pure sphere. This I didn't press it. Neither I gave a couple to it. But what did I do with this box? I removed, you know. I removed some part of it and produced an ellipse out of it. You don't understand, no? Similarly, if I just add cards like this, you know, alternatively I add cards. Instead of removing, if I add cards, ऐसे card करके addition करूँगा, what will happen to this circle? This circle will become also an ellipse. Other way, you know. ऐसा ellipse बन जाएगा. Both case ellipse will be made, but the process is not this. Process is something else. So this is called, by making a volume change, this is called a volume change. Or in 2 dimension you can say an area change. By making a volume change, you can also deform a rock. You need not press, you need not couple it. But if you just change the volume, also rock can be deformed. So that is to understand also. See, in many areas, you know, where the flow of material is there from surrounding. Suppose you have sedimentary rocks, and from below, you know, there is a magmatic granitic body, granite body, and this granite material goes and puts inside this, you know, along some foliations. So either the volume will increase or volume will decrease, you know, depending on the material you are removing it or material you are adding. So a circle will become an ellipse. Suppose you have a fossil, suppose. Here there is a palisade board fossil or graptolite fossil. Some fossil is there, you know. It is a fossil. So if you remove these materials, how the fossil will look like? The fossil will be like this. ऐसे fossil बनेगा. Deform हो जाएगा. Though you have not put any strain on it, though you have not pressed it nor coupled it, still then rock will be deformed if there is a change in volume. So this is called volume strain. This is different from that. In this connection, I will draw one section. Let's see whether you will be able to understand or not. Now suppose I am drawing a die here. This is a die. This is dolerite die. The field you got a dolerite die like this. What is your interpretation? How to interpret this, a die having this type of disposition? Die, class length. One piece is here, another piece is here, another piece. How do you explain these things? Huh? Fault. This is a fault. You see how erroneous you are? I will tell you. Initially, the die was like this, you know. Initially, the die was like this. What I did, you know, मैं इतना मटेरियल रिमूव कर दिया, डिसोल्यूशन हो गया, उड़ गया, फिर इधर उड़ गया इतना, ठीक है ना? मटेरियल इतना उड़ गया. Then ये पीस को यहाँ लेकर रख दिया, ये पीस को इधर लेकर रख दिया. Vertical. You see how they will appear this. Without also fault, you can produce a offset like features if there is a dissolution. Dissolution. होगा कि नहीं होगा बताओ? नहीं समझा ना? आप क्या करते हैं? ठीक है ना? ठीक है। अब मैं आई जस्ट रिमूव सम मटेरियल, डिजॉल्व हो गया इधर। So some acidic solution, groundwater solution, percolated through it. So this part of the rocks and materials, everything got removed. तो ये तो vacant space नहीं रहेगा. You cannot keep a vacant space inside a rock. Out of this load, this will come down, this will go up. ऐसे हो जाएगा. So the rock structure, you remove some material. तो क्या होगा फिर उसको? ऐसे हॉरिजॉन्टल कैप बन के रहेगा, वो तो कोलैप्स करेगा।
लिस्ट्रिक फॉल्ट
नहीं, लिस्ट्रिक फॉल्ट किधर है? ये तो खाली प्रेस कर दिया, मतलब भाई वो इट्स वेट,
तो लिस्ट्रिक फॉल्ट में वेट कितना सिर्फ होता है।
लिस्ट्रिक फॉल्ट कैसे होता है? सपोज ऐसे लिस्ट्रिक फॉल्ट इज ए कर्व्ड,
सर सब्सिडेंस तो नहीं होता।
इसमें सब्सिडेंस कैसे होता है? नाउ you want to take this block downward, normal faulting means you want to take this block downward. So how this block will go down? Now this will rotate, this block will rotate. As a result, this part will become like this. This is a listric fault. Here dissolution नहीं होता है, no dissolution, they only faulting activity. हाँ,
लेकिन आप बैंक में डिवीजन
हाँ,
how can you how it's possible to dissolve for some part in the tank, because not tank is discounted body and its strength is really
कैसे dissolve होता है? कैसे? Now आप you must have read in economy जो supergene enrichments. Supergene enrichment कैसे होता है? How the material is distributed and some part is removed ना, by what? Dissolution ना. इसीलिए तो मटेरियल गोज फ्रॉम द टॉप डाउनवर्ड एंड डिपॉजिटेड बिलो यू. तो ऊपर जो डिसोल्यूशन हुआ, व्हाट विल हैपन टू देम व्हेन दे स्टैंड लाइक दिस, कीपिंग कैविटीज लाइक दिस? दे विल कोलैप्स, दे विल कोलैप्स. So if they collapse, this part will come down and cross this part. See, इतना डिसॉल्व हो गया, ये इधर है, ये इधर है. There is a gap, Gap cannot stay for long, so this part will come down. When this comes down, what happens? It will start from here. There won't be any continuity. As a result, what you see, a fault type of offset. So it is not a fault. Though it is not a fault, you will get a fault type of offset. So this is because of dissolution. Material is removed from the mass and deposited somewhere else. So this block, this block, if you remove like these substances from here, they will be pressed.
Sir, but how can you identify this is not a fault and this is the solution?
That will find you. So you keep your eye open that I have two options. That is what I am telling you. Don't say it is a fault always, it would be a dissolution feature also. Understood na? So now you have to search for or look for a evidence whether it is a dissolution activity or it is a faulting activity. You have to find out. You have to understand this part na. So always an offset na is not an indication of fault. It could be also because of volume change, dissolution or volume change. See, many of these economy geology, those who are working in the economy geology, see there you people deal with dissolution of the materials, mass movement, mass removal, So from quartz vein, the material goes and be deposited some other place. There you see this type of features. Many such features, in ore deposits. So this is not the case always, it is fault. It could be also because of dissolution. So that is called a volume strain. Now, point is, when we are discussing these two things, let us not bring this part into mind. इसको बाद में करेंगे हम. What is its effect, on them? It's a very complicated process. Suppose you are pressing it, same time also you are removing some materials. How things will behave? Suppose you are coupling it or decoupling it, you are bringing this type of things. So better not to bring this type of things into mind now. Okay, but you keep in mind that there could be a situation where volume change may also result, this type of thing. Understood, na? So now we are left with these two things, pure shear and simple shear. So in this case, first what we will do, now imagine this case first. Right? Is it okay now? It's not becoming complicated now in your understanding. See, just imagine there is a sphere inside. There is a sphere inside. Have you seen what I mean? Wow, that sphere, I will draw it here. The inside it will be difficult for you to understand. Both directions, 1 centimeter. This side is 1 centimeter. Vertical is 1 centimeter. Unit dimension, 1 centimeter, 1 centimeter. So this cube is also 1 centimeter. This is 1 centimeter. This is 1 centimeter. This is 1 centimeter. Like that, a sphere is inside. So now what we are going to study, the sphere is inside. Then we are tracing from this side. So this sphere will change this dimension. This dimension change हो जाएगा. This will change. This will change. This will be reduced. 1 will become something 0.8, 0.7. हाँ? कौन सा? इसका रेडियस है ना 1 ना? इसका रेडियस 1 है.
डायमीटर
हाँ? इसका?
वो डायमीटर
ठीक है, कोई बात. मैं क्या बोल रहा हूँ? यूनिट डायमेंशन. That is what I am coming to picture, जो भी लेना है इसको 1 समझो आप. 5 सेंटीमीटर 7 सेंटीमीटर कोई मतलब नहीं मेरे को. कोई इतना बड़ा क्यूब लेना है, इतना बड़ा क्यूब लेना, मेरे को कोई मतलब नहीं है. मैं ले रहा हूँ एक यूनिट. समझा कि नहीं समझा? हाँ? So this 1 centimeter will become reduced. This 1 centimeter will become little extended. इसको क्या होगा ये 1 सेंटीमीटर को? यार अंडरस्टैंड पॉइंट है. एक बॉक्स का अंदर एक बॉल है. आई एम प्रेसिंग फ्रॉम दिस साइड. सो दिस बिकम्स 1.25. दिस बिकम्स 0.8. मैं इसको क्या करूंगा? ये भी होगा ना कुछ, क्योंकि यू आर प्रेसिंग फ्रॉम दिस साइड. हाँ? इंक्रीज डिक्रीज नहीं हो सकता. एक तो सोचने के बाद, suppose a ball is there, I'm pressing from this side, you made it like this, you made it like this part क्या होगा? Can it happen both extension as well as contraction? हो सकता है कि नहीं हो सकता? क्यों आप ऐसे सोच रहे हैं? मैं बोलूँगा नहीं contraction. नहीं हो सकता है contraction, छोटा नहीं हो सकता. सोच नहीं सकते ना. बात आप देखो, यहाँ जो प्रेस किया, मटेरियल यहीं निकल गया. आप जब यहाँ से ला रहे हैं प्रेसिंग, मटेरियल विल गो आउट लाइक दिस. मैं इतना मटेरियल यहाँ निकाल दूंगा, ये जो मटेरियल है ना, इसको भी खींच के ले जाएगा ऐसा. अब सोचो एक सिचुएशन, ऐसे भी हो सकता है ना. आप देखो, आप क्या समझते हैं? ये जो बॉक्स है, ये दो साइड ओपन है. This side is also open. I am pressing from this side. So equal amount of material will go outside. Both will stress. It can also happen. Suppose मैं this ये window को बंद कर दिया. I close this window. So material will only go this way. So nothing will happen to this. I may remove large amount of material very fast. So from this side material will come inside. So anything can happen to this dimension, depending on आप क्या रख रहे हैं इधर, what type of boundary you are keeping. You are understood this? It can extend, it can remain same, it can also be reduced. Anything can happen to it. So this, it could be this. Anything can happen. डिपेंडिंग ऑन द बाउंड्री कंडीशन. आप क्या उधर क्या रखते हैं? व्हाट आर यू कीपिंग देयर? आर यू कीपिंग इट फुली ओपन? आर यू क्लोजिंग इट? You have to keep this side open, you know. This side anyway it has to be open. Otherwise material कैसे जाएंगे? So this side, depending on what boundary condition you are putting, you know, it could be 1, no movement. It could be more than 1 if it is open. If it could be less than 1 also. If this dimension is very fast to move, you know. Anything can. Understood this part or not? अभी हम एनालिसिस करते हैं प्योर शेयर सिंपल शेयर. लेट अस मेक इजी एनालिसिस वेयर दिस डायमेंशन, यू नो, दिस डायमेंशन डज नॉट एक्सटेंड नॉर कंट्रैक्ट नॉर इट रिमेन्स फिक्स. देन ओनली आवर एनालिसिस अंडरस्टैंडिंग विल बी क्लियर. आप इसको अलाउ कर देंगे तो कुछ होने के लिए, देन वी कैन नॉट अंडरस्टैंड व्हाट हैपेंस दिस वे और व्हाट हैपेंस दिस. लेट अस कीप दैट डायमेंशन कांस्टेंट. इसमें एक ऐसे will keep a boundary in such a manner, you know, it always the sphere touches that boundary. It does not neither move inside or push outside. It remains fixed. You understand this part? So what type of situation I am putting it before you? It is a situation where this sphere, you know, this dimension remains 1, this dimension only grows, and whatever it grows, you know, it comes inside. That type of. So this ellipse, you know, if these dimensions are 1 and 1, let us make it 1.25. This will become 0.8. Other dimension, you know, the third dimension will remain 1. I will tell you from where I got this figure. Why I am putting these figures? You see, when I am pressing it, this material, whatever will come inside, they will only go outside. Because this dimension you are keeping constant. This dimension you will keep constant. Now, what is the volume of this sphere? Volume of this sphere is 1 into 1 into 1. तीनों को multiply करेंगे तो volume will come out. Now, when I am changing it, suppose I am making 1.25 one dimension, other dimension is 0.8. This will be also 1. You see? That is why I got these figures, so that the multiplication will be 1. So no volume change, no volume change. Am I becoming little, you know? No volume change. So only one dimension will grow. Grow at the expense of other. I made it further clear, don't worry. I think the face is not clear. मैं suppose इसको 2.5 करता, I press so much this becomes 2.5. तो ये dimension कितना होगा? What will be this dimension? कितना होगा बताओ आप सर? Only 0.4 होगा. Because these dimensions are not changing 1. So multiplication of these 3 will be 1. That is what I am telling. Again, I will just fix and make it further clear, you know. Suppose you always think it is unit dimension. Huh? I am dealing with a unit circle or unit dimension. This is 1, this is 1, this is 1. Whatever, the 3 centimeter it put, but 3 centimeter I am taking as a 1. Unit dimension means that diameter ho ya radius ho, it is 1, 1, 1. Now when I am making an ellipsoid out of it, you know, so these dimension and these dimension, you have to make vary. Because this is 1, this will remain 1. That we are not changing. Understood na? Only these 2 dimensions only are changed. Suppose I am making one side is 1.25, other side will कितना होगा? 0.8 होगा ना? This will be 0.8. So that this multiplication will be 1. A will be 1.
why we are taking only means why we are taking the multiplication?
Volume.
Sir,
Volume remains constant.
Sir,
What is volume of this?
what is the volume of a sphere? Sphere is 4 by 3 pi r cube.
4 by 3?
Pi r cube.
अच्छा, we have not got that one. R क्यों ना?
Yes sir.
यही है ना?
हाँ.
Ellipse क्या?
हाँ वही sir.
4 by 3 pi यही है ना? Multiplication of 3 axis is the volume of the sphere. Multiplication of the 3 axis is the volume of the ellipse. ये तो constant है. Understood or not? Tell me. So 4 by 3 ये तो only this R matters, you know. This axis length matters. नहीं समझा अभी? हाँ? नहीं समझा?
समझा बट मुझे इलिप्स का वॉल्यूम का फॉर्मूला याद नहीं.
यही है ना?
नहीं सर वो नहीं है
कौन?
हाँ?
सर पाई भी एरिया होता है
पाई?
सरफेस का वॉल्यूम करते हैं
आप बताओ फॉर्मूला मेरे को तब तक देखो मालूम नहीं है. It is 4 by 3 pi r cube. It is 4 by 3 pi a into b into c. कैसे जानते हैं? आप किसके पास कंप्यूटर नहीं है?
Wi-Fi is not
You might have forgotten it. But that is the volume of a ellipse. Volume of a sphere is cube. ठीक है ना? ये इसका तो वैल्यू नहीं रहता है. इसका कोई both sides have to be equal. ठीक है? हमें समझा? हाँ? So when I am making see all these things see fine. This is 3 dimension na 1 1 1. Now this dimension I am keeping constant. So I am leaving this part, only seeing these two parts. This is 1.25. This will be 0.8. If I am making a larger ellipse, if this is 2.5, I have to make 0.2. That is the thing. So that area or the volume remains constant. Because first we rule out the volume change. Volume change अभी नहीं लेंगे हम consideration करेंगे. Volume change we will bring it later. अभी only we are thinking of volume remaining fixed. This is how the dimension will change. Follow this point now. Other dimension is always 1. Always 1. So now this becomes x axis, this becomes z axis, this becomes y axis. 3 axis now different. So x is equal to y is equal to 1, z is equal to a. This is how the axis of the ellipse is distributed. You want the concept कहाँ से आया समझा? हाँ? मैं वही सोच रहा हूँ आप MSc ठीक पढ़ा नहीं है really? हाँ? I am only teaching the first class of MSc course. मैं यही चीज कभी भुवनेश्वर आगे पढ़ाया है MSc स्टूडेंट को. मैं वही ताजुब हो रहा हूँ. क्योंकि इसके मतलब मैं थोड़ा डीपर जाऊँगा. समझा ही नहीं समझा मेरे को. हाँ? वेरी इजी, कोई डिफिकल्ट नहीं है. ठीक है ना?
सर लेकिन ऐसा पॉसिबल है क्या मतलब कि इफ यू आर नॉट चेंजिंग द विड्थ एंड यू ओनली elongate it is possible
हो सकता है.
सर आप जब लेंथ बढ़ाएंगे तो विड्थ ऑटोमेटिकली कम होगा ना
अभी तो ऊपर से कम हो गया ना. आप एक टेक ए बॉल लेके ऐसे बॉल रखो, आप यहाँ से प्रेस कर दो, यहाँ से व्हाट विल हैपन, दिस साइड विल बल्ज. ये साइड बॉल नहीं करेगा.
सर लेकिन वन का उसका डिफरेंस होगा
कैसे वहाँ बंद करके रखे हैं ना. यू आर क्लोजिंग ना, यू आर कीपिंग ए बाउंड्री देयर ना. आप खोल देंगे तो वो चला जाएगा. है कि नहीं? एलिप्स का डायमेंशन समझा कि ना 1.25 0.81 कैसे आता है ये चीज या 2.5 0.41 how it comes into picture. Now you can change it now. See, this is 1, you can make it 1.25. Suppose there is no boundary. 1 point you can make it 1.25. Then this dimension will change now. The volume has to be 1. So when you change this from 1 to some other value, this value will be definitely different. The multiplication will be 1. That is, we are keeping the volume constant. You don't understand this part. Suppose I am telling as it was, suppose this part y became 1.2. Suppose 1.2 ये हो गया. X become 1.8. Now what is z value? Suppose x becomes 1.8, y becomes 1.2. What will be z? So 1 divided by 1.8 into 1.2 ना. तो कितना आएगा? How much will come? फिर देखो, फिर आपके पास कैलकुलेटर नहीं. Understood now what I am doing? So let's see, this part is very prime. So this y value can have any amount. It could be more than 1, it could be less than 1. But we are assuming, before you go to those situations, we are assuming keep this as constant. Don't touch that. Only this maximum value make it bigger and the minimum value make it smaller. This value will not touch now. We will touch later. So what will be the value of z now? 0.4 indeed. So the total will become 1. So total this will become 1, That is the concept. The volume remaining fixed. Understood now? Here volume is fixed. So the ellipse can be of any type. But we are only considering this ellipse where y is equal to 1. Others को खाली हम change करते हैं. You can make any variations in y values. You don't understand na? And imagine a situation, you put volume change over it. ये तो volume change नहीं है, volume is remaining constant. You can think of a volume change over it. Total multiplication will not be 1. It may be more than 1, may be less than 1. देखिए कितना structure निकलेगा. The structural theory is so vast. Because you are considering the deformation is by pure shear and simple shear. This strain ellipse. This is an ellipse. Ellipse will tell you what type of structure will develop. Now when the ellipse has so much of variation, unless you understand so much of variation, the structures you cannot explain. Okay. But anyway, don't go to complication. Only you think, just like a baby, x is equal to more than 1, z is equal to less than 1. Y को आप fix करो. Gradually you try to understand, then only you will make it go to complicated issues. Okay. So, when you are making an ellipse like this side become 1.25, this becomes 0.8. You remain 1. You understand this picture now, na? Similarly, this ellipse also you can think that way. This is 1.25. This is 0.8. Other side is 1. We are only discussing about this ellipse. Other side is 1. इसमें 1 कर देता हूँ. Both ellipses are same. But only difference is here there is a external rotation. The external rotation is there. Here there is no external rotation. You are producing an ellipse, same dimension. Here also you are producing an ellipse, same dimension. But here there is an external rotation which is not there. ठीक है ना? माइंड में गया ना था वो. So here only another value, psi value is coming in. External rotation. Now, the simplest is this then. When there is no external rotation, this is the simplest one. When you are bringing external rotation, it must be having a relation with this strain ellipse. That we will discuss little later. First let us see the easiest one. If this easiest one you can understand, gradually things will be very easy. Okay. Next thing, कितना आप understand किया? So, what we are discussing where the strain ellipse is this dimension. Key dimension. You understood this value name, na? It could be 1.25, it could be 2.5, but this will be what? This we can say y is x, this is z. So where y is equal to 1, that is called a plane strain situation. Plane strain. Plane strain. If y you are changing, it could be y is more than 1, it could be some flattening. We will discuss these things later. If y is equal to less than 1, it could be constriction. Constriction. These two things we will discuss later, but first let us discuss this plane strain situation. Plane strain you understood, no? Y is equal to 1. Constriction. अभी तो क्लियर है ना? नो प्रॉब्लम ना? ठीक है, देखते हैं. If you want me to move still in a very slow way, also I can move. Absolutely, you have to understand, you know. ठीक है? अच्छा, आपको दिखा रहा हूँ. थोड़ा I will take a break. थोड़ा सा मैथमेटिक्स बोल दूंगा आपको. This becomes, say, 1.25. This situation, na? Can you tell me what is this? E is equal to final length, initial length of a E is called strain. ठीक है ना? Final length of another part is E plus 1. ये वैल्यू कितना हो जाएगा? LF upon L0 हो जाएगा. This is called stretch. Stretch. Then E plus 1 का स्क्वायर जो है, स्क्वायर इसको बोलते हैं लैम्डा, और क्वाड्रेटिक लैम्डा. ये तो मोस्ट पहले का सब्जेक्ट है, कोई बड़ी बात नहीं है. रूट लैम्डा इक्वल टू ई प्लस 1. आप इतना लिखो, कोई बड़ी बात नहीं. रूट लैम्डा इक्वल टू ई प्लस 1 और 1 प्लस ई जो भी है एस. ठीक है ना? वही बड़ी चीज है. नाउ ठीक है ना? Now suppose I ask you a circle of unit dimension when तो ये plane strain हुआ इसको, okay, produce the dimension of this 1.25 and 0.8. Initially it was unit dimension. ठीक है ना? Now this dimension and these two dimensions can be represented as देखो सर, पहले 1 थे, ये 1.25 हुआ, 0.8 हुआ. So this can be represented by root lambda 1 and root lambda 2. What is, if it is 1, it is 1.25. What is the root lambda 1 value? 1.25 na. Final length upon the initial length is the root lambda 1. Root lambda 1 is equal to LF minus L0. थोड़े फैक्टर लेके रहो. Okay. So this dimension is root lambda 1, this dimension is root lambda 2. So if a unit circle is deformed, then the ellipse which is an ellipse which is going to be produced has dimension of root lambda 1 and root lambda 2. ठीक है ना? So this I am writing. Of unit dimension, if you undergo the plane strain, then the strain ellipse will have a strain ellipse has dimension of root lambda 1 and root lambda 2. ये बात अंडरस्टैंड किया कि नहीं? वैल्यू का कोई मतलब ही नहीं है. It is root lambda 1, root lambda dimension. Suppose I will give another example. Unless this sets in your mind, कोई मतलब नहीं पढ़ाने का. मैं बताता हूँ. So let us take 2 centimeter radius. This is 2 centimeter radius. This is 2 centimeter. Now I am getting an ellipse 2.5. This becomes 0.6. Two centimeter था, it became an ellipse like 2.5, 1.6. Is it correct? Because 2 centimeter radius का था. What is the area? 4 ना? Area is 4. What is the area here? If you multiply also 4 na? So okay. So this became this. Now, what is the root lambda 1 value here? What is the root lambda 2 value here?
0.8
Huh?
0.8 and 1.1.
That is what I wanted. Root lambda 1 value is 1.25. 0.8. Not this. What is telling a unit circle? You have to start with an unit circle and make it like this. So इसको आप 1 समझना पड़ेगा. If it is 1, then it has to be half. It has to be half. So unit circle का dimension जो होगा, that will give you root lambda 1, root lambda 2 value, not the actual value. Understood this? Up, whether you take a small circle or a big circle, does not matter. अब strain जो हो रहा है, bigger circle will make bigger dimensions, smaller circle will become smaller dimension. But you see this ratio. The ratio you see, final length upon the initial length, you know, that is your quadratic elongation. Not this value. इसका final elongation upon this initial. That is the what root lambda 1. Understood this part? I should make it little clear further. Let us see. Similarly, just you can get a, suppose a 5 centimeter radius circle become a ellipse or this becomes 8 centimeter. 5 centimeter become 8 centimeter. इसका निकालो आप strain निकालो. What is the root lambda 1 value? What is the root lambda 2 value? निकालो आप. कैसे निकालो? हाँ?
1.6.
This one. 8 by 5. So 1.6. So this becomes 1.6. What about this?
Not fast.
हाँ? एक बताओ कितना ये?
5 into 5 into 5 by 8 into 1 into
What?
20 to 5.
हाँ. So that means 5 into 5 by 8. यही है ना? So 25 by 8. So 3 point something होगा? हाँ? 3.1. यही ना? So 3.1 final length upon 5 is root lambda. This is root lambda 1. 0.6. Become 0.6. 0.7. Understand? So ये root lambda 1, root lambda 2, you should know from where it is coming. ठीक है ना? हाँ? You can calculate ना the dimension of an strain ellipse. So x is equal to root lambda 1, z is equal to root lambda whatever 3, y is equal to root lambda 2, this is equal to 1.25, this is equal to 0.8, this is equal to 1. देखो सर वैल्यू देखो सपोज ये कंसीडरिंग an ellipse, पूरा ellipse है, x becomes root lambda 1, z becomes root lambda 3, y dimension remains same ना, so that is 1. नहीं? So along x dimension it has undergone extension. It has undergone extension. Along z dimension it has undergone shortening. So here no strain. No strain. होगा ना उत्तर वेरी इजी बट थोड़ा सा आपको प्रैक्टिस करना पड़ेगा टू बी acquainted with this also. So this root lambda or lambda whatever it may be gives you longitudinal strain along a line. Longitudinal strain along a line or along a direction, but there is a change in length, that is called longitudinal strain. So along this there is a extension, along this a contraction. So these dimensions or these directions has undergone longitudinal strain. ठीक है, अब तक समझा? डाउट तो नहीं रहा अभी तक, और आई रिपीट सम पार्ट. Suppose I will ask you, suppose there is a facile like this, some facile का ये एक लाइन है, ये लाइन, lines are there. After deformation, the facile become ऐसे हो गया, facile ऐसे, very long. So I will ask, what is the quadratic elongation along this line? Along this line क्या quadratic elongation? कैसे निकालेंगे आप? Say, if you know the original length and this is the final length, just a ratio final length upon the initial length. If you know the original length, final length is with you. Similarly, if I ask you what is the longitudinal strain along this line, you are seeing these things. You do not know what was there. If you know the original length, final length, just take a ratio. That is the quadratic elongation, root lambda, कुछ भी बोलिए आप. These are longitudinal strain, change in length. Understood ना? So next class what we will discuss? Change in angle. Change in angle. Otherwise you cannot understand this pure shear strain. Is it clear or not? Tell me. Longitudinal strain. ठीक है. देखते हैं. So unless it sits in our mind ना, discussion